All right, we're going to look at 7-6, which is solving equations with radicals. This is a new type of equation for us. It comes with a new set of rules. That's what we're going to first cover. So this is such an example that we're going to work on. We have a radical here, and we have to understand the process to solve this. So first, we want to isolate the radical. That means get the radical alone on one side. Then we're going to apply the power rule. This means that we raise each side of the equation to a power that matches the index. So remember, the index is the root you're taking. So if we isolate a square root, that means we raise each side to the second power. Once you do that, these radicals should cancel out. Now, sometimes it's the case that not all radicals cancel. So if the equation still contains a radical, we have to repeat steps 1 and 2. Then you're going to solve the remaining equation, and you're going to check your solutions. This is not an optional step, but rather a requirement. You must see if they work or not. So let's try it out. The first one is square root of 3k minus 2 minus 8 equals 2. So the first thing we're going to do is we're going to add 8 to isolate our radical. So we get the square root of 3k minus 2 equals 10. Now to get rid of the square root, we're going to square both sides. We're going to take the square root of 3k minus 2 and we're going to square it. And we're going to take 10 and we're going to square it. When you square a square root, they cancel each other out and you're left with the radicand. 3k minus 2 equals 100. This, I apologize, is actually a negative 2, so this would be 6, 6, and 36. It didn't print very well. So now we have 3k equals 38. When we add over our 2, we're solving now a simple linear equation. We divide by 3 and get 38 thirds. Now you have to check your answer. What do we mean by that? We mean you must replace k with this fraction and see if it works. So you're going to take the square root of 3 times 38 thirds minus 2, and then minus 8 equals negative 2. Now you certainly can do all of this work with your calculator if you would like. You could also do it by hand. Your 3's drop out, so you have 38 minus 2, which is the square root of 36 minus 2 minus, whoops, this is all over that. No, sorry, that's not there. So then you get 6 minus 8 is negative 2, which checks out. So you can keep your answer there. All right, so all this checking work is required, but you can plug it all in your calculator to do so. The next one, we can see that a square root is already isolated, so we square both sides. So we take 3 square roots of x and we square it. And we take the square root of 8x plus 9 and we square it. Now here, we have to use the power rule. The power rule means that everything inside gets squared. So then 3 becomes 9, and the square root of x squared becomes x. This becomes 8x plus 9 because when you square a square root, it cancels. Now we're going to subtract our 8x, and we get x equals 9. And then it does check. If you plug it in, it works out. So for 3, we first need to move over our 5. we get the square root of r squared minus 15r plus 15 equals r minus 5. You're now going to square both sides. So you're going to take that whole square root and square it, and you're going to take r minus 5 and you're going to square it. When you square this square root, it falls out, so you get r squared minus 15r plus 15 equals. Now this you have to be very careful with. This is a binomial, and the only way to square this properly is to write it twice and to FOIL. So we get r squared minus 15r plus 15 equals r squared minus 10r plus 25. Minus 10 because you have a minus 5 in there twice. Now to solve this, you're going to begin to combine like terms and your r squareds fall out. Now it's a linear equation because there's no longer any power. So I am going to add my 10r, and I'm going to subtract my 15 because I want my r to be on one side and my constant to be on the other. So I get negative 5r equals 10. When I divide, I get r equals negative 2. Now every time you solve an equation involving a radical, you must check your work. So if we would check that r equals negative 2 in that equation, we would find that it fails. So when checked doesn't work. So what that means is this is the only answer we got and it doesn't work, so we end up with no solution. Problem 4. The square root is already isolated. It's okay if there's a coefficient in front. There just can't be any plus or minus. So we're going to take 4 square roots of x plus 6 and we're going to square it. And we're going to take x plus 9 and we're going to square it. So right here, this is not a binomial because there's no addition or subtraction. So you're going to use the power rule. So you're going to take 4 and square it and get 16 times x plus 6. When you square a square root, it cancels, but this multiplication between parts is still here. Then you're going to take x plus 9 and you're going to write it twice because that is a binomial and therefore needs to be FOILed. So you're going to distribute the 16 and get 16x plus 96. And you're going to get x squared plus 18x plus 81 when you FOIL. Now, we're at a point in the semester where we need to recognize what types of equations we're going to have to finish solving. This equation is quadratic because of this power of 2 term. That means that this equation must be set equal to 0. So we're going to subtract 16x and we're going to subtract 96. So you get x squared plus 2x minus 15 equals 0. The next step of solving a quadratic equation is by factoring. So we have x plus 5, x minus 3. You set each one equal to 0 and solve. So x is negative 5 and x is 3. You must check those answers back in this equation. Each one. So you put negative 5 everywhere you see x and you see if it works. You put 3 everywhere you see x and you also see if it works. It is the case this time that they both work. So sometimes what's going to happen is nothing works and you get no solution. Everything works, so you get to keep it. And there's also an instance where you might get 2 answers and only one will work. And that's exactly what happens on the u-try problem. So the u-try problem would start by adding the 3 over. So you get the square root of 9 minus x equals x plus 3. You're then going to square both sides. So this becomes 9 minus x. This you're going to write twice to FOIL because it's a binomial. So you get 9 minus x equals x squared plus 6x plus 9. It's quadratic because of the power of 2, so you want to set it equal to 0. So I get x squared plus 7x equals 0. Now this might be a little tricky to factor if you have forgotten what to look for first. When factoring, you look for greatest common factor first, which these two terms share x. So I'm going to factor out an x, and I get x is 0 or I get x is negative 7 when I solve each of those. If I check these answers back in this equation, I will find that this value of negative 7 does not work. So the only answer I can keep is x equals 0.